section 5.7, completing the square. Our objectives are to solve equations by completing the square and to rewrite functions by completing the square. So for completing the square, it's just another method to solve quadratics. It helps us find the exact solutions instead of using our calculator and getting rounded answers. So remember, we have factoring to help us solve, taking the square roots of both sides, and then we showed how to solve equations using your calculator. Now we're going to solve our equations by completing the square, and this helps us find our exact solutions for problems that we can't factor or take square roots of. So for this, the purpose of completing the square is to transform a binomial with a quadratic and linear term into a perfect square trinomial. For these problems, the coefficient of the quadratic term must be 1. If it is not 1, then you're going to divide the equation by the coefficient of the quadratic term, and we'll talk about what that means in a little bit. So below is a diagram which shows the process of completing the square on x squared plus 6x. How many yellow tiles do we need to complete the square below? What is the perfect square trinomial in standard form and in factored form? So if you look here, we want to figure out how many of these little yellow squares do we need in order to complete this square that we have over here. So if you look, if we were just to kind of maybe draw in lines, those would represent the 1 tiles, and how many more would we need? Well, we would need 9 more. And if you look at this square, notice that this side over here is x, and then we have plus 3, these little green tiles, and over here we have x plus 3. So for this, that means 9 more little squares make it a perfect square trinomial. So we would get x squared plus 6x plus 9 more. So this is my perfect square trinomial in standard form. And remember, standard form is ax squared plus bx plus c. Now for this, if we were to factor this, remember we would set up our 2 sets of parentheses, and we want factors of 9 that add up to 6. Well, that would be 3. So x plus 3 and x plus 3. And notice that that's the length of the side of the square that I have here. Also, we can combine this into 1 and write this as x plus 3 quantity squared. Now, this would be the factored form. And just a couple of little things to look at. Notice that for our perfect square trinomial, since it's a perfect square that we're talking about, we're always going to have something that's going to be the same number. And if you look at this number 3 that we had right here, notice it's half of the linear term. Which was 6x. And also know that if you square 3, you get 9, and that makes sense because if you were to FOIL out this factored form, you should get the perfect square trinomial that we have on top. So 3 squared would be 9, so it's half the linear term, and then the last number is half your linear term squared to get this 9 right here in order to complete this square that we have over here. So to complete the square, you find the last term of the perfect square trinomial. And again, to get that last term, it's going to be by doing half of your linear term squared. So the last, to complete the square, it's going to be, I'm going to write it over here, half the linear term squared. And so that's what you're going to hear me say a lot. So now for these next examples, it says, what must be added to make a perfect square trinomial? Then write the perfect square trinomial in factored form. So if we look here, we have x squared plus 4x. Now using our logic from the last one, I want half my linear term squared. So what's my linear term? The 4x. So I'm going to do this off to the side. So I have 4x. I want half of that. So divide it by 2 or multiply it by half. So half of this is equal to 2x, and then remember we said when we write it out, I'm sorry, and we don't use the x actually, so half just the coefficient, I should say. So half of 4 is 2, so then we take that 2 and we square it, so 2 squared is equal to 4. So to complete the square, we need 4 more. And now I'm going to write this in factored form just to show you. So if I write this in factored form, we would get x plus 2 times x plus 2. and then this would become x plus 2 quantity squared. And remember, since it's a square, that's why both of these have to be the same, because each side has to be the same in a square. And if we were to FOIL that back out, we would get x squared plus 4x plus 4. So the 4 must be added to make it a perfect square trinomial, and then this would be the factored form. So let's do B. So looking at B, again, you take your linear term, which is 9. So, and in this case, notice it's negative 9. So negative 9 divided by 2 is what I'm going to use. For that, because this doesn't give me a nice number, I'm going to leave it in fraction form. And remember, it's half your linear term squared. So half of 9 squared. And in this case, this squared right here would be plus 81 over 4. So that's going to be what completes my squared. So now how do we go in our factored form when we have this kind of fraction here? Remember that this number is half your linear term squared, but half your linear term is what goes right there for the factored form. So in this case, if I write x, and then since it's minus for my linear term, I'm going to use minus. So minus 9 halves and x minus 9 halves. So if I take 9 halves negative times negative 9 halves, I get positive 81 over 4. And if you do FOIL this out, you would get 9 halves x and 9 halves x. So if you have 9 halves x minus 9 halves x, I'm going to write that out. Well, you need a common denominator in order to add them, so this gives you negative 18 halves x, and negative 18 halves x is really equal to negative 9. So notice that if I were to FOIL that out, I would get that middle term 9 that I had before. So then this would be x minus 9 halves quantity squared. So this would be my factored form, and this completed my square. So for the next one, let's go ahead and just skip this one for right now. We'll talk about when we have a coefficient in front in a little bit. So you can solve any quadratic equation, again, by completing the square. You will either have real solutions or imaginary solutions for a quadratic equation. Now, these are the steps that we're going to do in order to complete the square. So remember that the coefficient must be 1, if not divided by that coefficient. Move the constant term to one side by itself. It's always half the linear term, and then you square the number from step 3. And then we're going to add it to both sides, and then we're going to write it in factored form and then solve the equation. That's the next steps that we're going to do. So for these, it says solve each equation by completing the square. So for this problem, on this one, I could actually, look at this. And so if I want to complete the square, the first thing I would want to do is I want to take that 4 and put it on the other side. Now for this, if I wanted to try to factor this without completing the square, we would look for factors of negative 4 that add up to positive 4. So if I did that, I would have x here and x here. So then I would say, okay, well, since this is a minus on the end, I know that my signs have to be opposite. So do we have factors of 4 that add up to positive 4? No, because 2 and 2 won't work, and 4 and 1 won't work either. So that's why we are going to complete the squares, because I can't factor this. So the first thing you do is take that number to the other side. So we get x squared plus 4x plus something that's going to complete my square equals, and I took the 4 to the other side, and what you do to one side, you also have to do to the other side to make sure you balance your equation. So I want to figure out what is that number going to be that completes my square. Well, it's going to be half my linear term, so I'm going to do my math off to the side. So half of 4 is 2, and then we're going to square it, so 2 squared is 4. So remember, it's half your linear term squared. So what we do to one side, we do to the other. Now that I have that, I can go ahead and factor my equation. So now this factors into x plus, not 4, but x plus 2 times x plus 2 equals 8. And then, of course, now we can write this as x plus 2 quantity squared equals 8. And now that I've done that, I can solve this equation because we've learned that I have this part isolated what's being squared, and so to get rid of that squared, I can take the square root of both sides. Don't forget, when you're getting rid of an even power, you need to do the plus or minus. So this would be x plus 2 equals plus or minus the square root of 8. The square root of 8 reduces, so x plus 2 equals plus or minus 2 root 2. And then, of course, I want to solve for x. So when I solve for x, I get x equals, take the 2 to the other side by subtracting it. So negative 2 plus or minus 2 root 2. These are my solutions for my equation. If I were to graph this in my calculator, I would get the decimal version of these two answers that I have. So for this, again, you have two solutions. So one of them would be x is equal to negative 2 plus 2 root 2, and the other one is x is equal to negative 2 minus 2 root 2. And you don't need to write your answers like this. It's easier just to write it with a plus or minus, but I do want you guys to notice that because of that plus or minus, these are the two solutions that you get. And if you wanted to do it in your calculator to find the decimal version and then graph it, you could. So let's go ahead and look at the next one. So for this next one, we want to, if I take the 34 to the other side, I'm not going to be able to factor the equation. So we're going to complete the square. So I have x squared plus 6x plus some number equals negative 34 plus some number. So the constant was already on the other side, so we didn't have to take it over. Now remember, to complete the square, I take half my linear term, so half of 6, and then we're going to square that number. So half of 6 is 3, and 3 squared is 9, so that completes my square. And then I want to factor my equation. So when I factor my equation, it's always going to be half of the linear term. So this would be x plus 3, x plus 3. And then negative 34 plus 9 is negative 25. And then x plus 3 becomes x plus 3 quantities squared. That's going to help us and get rid of that squared so that we can solve for x. So now I can take the square root of both sides, so don't forget your plus or minus. So x plus 3 equals plus or minus the square root of negative 25. Remember, we just learned that we don't like to have negatives underneath a radical, so really that becomes x plus 3 equals plus or minus I, and this square root of 25 is 5, so I root 25. So that's going to be x plus 3 equals plus or minus 5i. And then I have to do one last thing, get x by itself. So I'm going to subtract the 3 to the other side. And when I do that, I get x equals negative 3 plus or minus 5i. So these would be my two solutions. Now in this case, this is one of those problems where you couldn't check this on your calculator because their solutions are imaginary. So it wouldn't cross the x-axis in order to check our solutions. Now for this next problem that we have for C, again, I would want to get everything together. If I try to factor this equation, it's not going to factor, so that means I have to complete the square. So I want to take that linear term to the other side. So I have 5x squared, and then I have minus 6x equals 8. Now remember, we said that you can only complete the square when your leading coefficient is 1. Right now our leading coefficient is not 1, it's 5, so that means I have to divide each of these terms by 5 in order to complete the square. So when I do that, I get x squared minus 6/5 x, and then I'm going to do something to complete the square, equals, and then we have 8/5 plus that same number that completes the square. So this one's a little bit different because that linear term is a fraction now. So to do this, we have negative 6/5, and of course we're doing half our linear term. So another way you can think about this is it's like multiplying it by half, and then we're going to square it. So it's a little bit easier if you do it that way. So this number right here is going to be negative 6 over 10 squared, and of course that just ends up being negative 3/5 squared, so this ends up being equal to 9 over 25 when you simplify that. So 9 over 25, 9 over 25. So now we want to factor this, and when I factor this, remember we said this factors into x, and since our linear term is negative, this is going to be negative in here. So minus, and it's always half the linear term, so this right here is really negative 3/5, and then we squared it to get 9 over 25. So x minus 3/5 times x minus 3/5 equals And then, of course, we're going to do 8 fifths plus 9 over 25 is 49 over 25. And you can use your calculator math fraction key to get that. Now that completed my square, so we can write x minus 3 fifths quantity squared so that we can solve the equation. And of course, now I want to take the square root of both sides so that I can solve. So when I do that, I get x minus 3 fifths equals plus or minus the square root of 49 over 25. We don't like fractions underneath radicals, so I'm going to separate the radicals and do root 49 over root 25, which is really just 7 over 5. So we get x minus 3 fifths equals plus or minus 7 over 5. Now for this, notice I don't have any radicals in my equation anymore. That means I can simplify this all the way by finding this number solutions that it's equal to. So I'm going to do my two answers. So I have x, and I'm going to take this to the other side by adding it. So x is equal to 3 fifths plus 7 fifths is going to be one of my answers, and x is equal to 3 fifths minus 7 fifths is going to be my other answer. And again, because there's no radicals and there are no imaginary parts in this equation, that's when you always want to simplify it completely so we can combine these because they're like terms. So that's why we're going to do that. So 7 plus 3 is 10 fifths, and 10 fifths is really just 2. And down here we end up with negative 4 fifths. So these are my two solutions that I get for this equation that we have right here. So what I want you guys to do is see if you can do D on your own. So do that out, complete the square, and then we'll look at it in class. So now we can rewrite a function by completing the square. Remember in lesson 5.3 we converted quadratic functions into vertex form by using x equals negative b over 2a to find the x-coordinate of the parabola's vertex, and then we substitute that value in for x. We found the y-coordinate of the vertex. Another way to rewrite a function is by completing the square. So remember that vertex form for a parabola is this equation right here, where h and k is the vertex. So for this a that we have right here, we can now solve this by completing the square. So for this one, I would just take out the y for now and then put in 0 and then complete the square and put it back in. So we're going to say that we just have x squared minus 10x, and then I'm going to take the 2 to the other side. So this would be plus something equals 2 plus that same number to complete the square. So completing my square, remember we said it's half your linear term squared. So in this case, I'm going to do that up here. So negative 10 over 2 squared, it would be negative 5 squared, which is 25. So 25 is the number that completes my square. And now I can factor this. So this becomes x, and since this is minus right here, it's minus 5 because it's half your linear term for that number, equals 27. And then we get x minus 5 quantity squared equals 27. And remember, for vertex form, notice that you keep your numbers like this in the equation, so the quantity squared and then plus k, so the only thing we have to do is take the 27 back to the other side and add our y back in. So y equals x minus 5 quantity squared minus 27. And that completed my square, and that's my equation in vertex form. And remember, you could check your equations by plugging them both into your calculator and seeing if you get the same graph. So remember, this is just one way to solve the problem. And the other way that we did before was we said, okay, the a value stayed the same, so a is 1, b is negative 10, and c is negative 2. So a stayed 1, which it is 1, and we can check our vertex by doing x equals negative b over 2a when you're in standard form. So in this case, negative 10 over 2 times 1 gives me 10 over 2, and 10 divided by 2 is 5. And notice that that was the x-coordinate of our vertex. And if we plug that back into our equation to solve for y, we would get negative 27. So our equation checks out. So let's go ahead and look at b and do the same thing. So I want to complete the square in order to put this in vertex form. So I have x squared plus 5x plus something equals -3, because I'm taking that to the other side, plus that same number. Now for this, what is that number that completes my square? Half my linear term squared. So half of 5 squared would be 5 halves squared, so 25 over 4 when you square that. And now I need to factor. So this is going to be x plus, and it's always half your linear term. So it's easy to find that number even if it is a fraction. And then on this side, when we do -3 plus the 25 over 4, we get 13/4. And now I have x plus 5 halves quantity squared equals 13 over 4. And then, of course, this would become, take the 13 over 4 the other side, so y is equal to x plus 5 halves minus 13 over 4. And don't forget that squared right there. So notice this would be my equation, and of course I could check it by graphing it, make sure the graphs are the same, or by finding the -b/2a for the vertex. So let's just go back to this other equation and practice finding our vertex. So remember here, our vertex for this one was 5, -27. Oops. And our vertex here would be, didn't ask me to do this, but -5 halves -13 over 4. Now for this last problem, notice this is a little bit different than the other two because we have our leading coefficient is not 1, it's now 4, so we have to do something a little bit different for this. Okay, so for this last one, remember when it's not 1, we have to divide that number out. So I'm going to divide everything by 4. And then remember to complete the square, I want to take my constant to the other side. And then so my linear term's -4, so -4 over 2, so half my linear term squared. So -4 divided by 2 is -2, and -2 squared is 4. So that completes my square. And now I get a factor, so this is x minus 2 and x minus 2. And then -1/4 plus 4 gives me 15 over 4. So this would be x minus 2 quantity squared equals 15 over 4. And then, of course, we would want to take that to the other side. So we get y equals x minus 2 squared minus 15 over 4. Now, this problem is not done because remember in the beginning of our problem, we changed the equation by dividing out that 4. And remember we said before when we were completing these problems, your a value should always stay the same value from standard form to vertex form. And notice right now we are missing that a value because we divided this a value out right here. So if a is 4, whenever you don't have a leading coefficient you divide it out, you have to at the end multiply it back in. Now on the other equations that we were solving up here, for these equations, when I divided this out, we didn't have to multiply it back in because we were just solving the equation. And when you're just solving the equation, it doesn't really change that. But when you're rewriting the equation, it does. So now that means I need to multiply that 4 back in. And when you multiply that 4 back in, you need to multiply it by both your terms in your equation. So in this case, I would get y equals 4, and then this would be x minus 2 squared, and then that 4 has to get distributed to the 15 over 4, so this would be minus 15. And now this is my equation. And so for this, my vertex, if I was asked to find it, would be 2, -15. So let's check our answer by using what we learned before. So I'm going to do x equals -b over 2a. So I'm going to check my vertex to make sure it's correct. So in this case, my a was 4, my b is negative 16, so I get negative 16 over 2 times 4. So this gives me 16 over 8. So notice that for this I get 2 for the x-coordinate of my vertex. So that checks with what we did. And if I were to plug this back into my equation for x, I would get negative 15. And again, you could also graph that. So remember, if you divide that number out, make sure you multiply it back in at the end and check your work. So again, bring this with you to class, and also make sure that you try this one right here, D, and then we'll talk about it and do some more practice of this.